can deal with the first question. The project itself is due to finish at the end of this month. So as part of the Ideas project, we will not be planning to extend the project work to other sites, but obviously in future research we will be looking to do this. Let me see the next question. There is a lack of harmonising. There is currently a lack of harmonising between European concerning aspects such as the definition of energy boundaries. Yes, the concept of an energy positive neighbourhood does supply a concept which could be applied across Europe regardless of existing frameworks. The whole concept of the energy positive label and the KPIs that we have developed is that they are applicable across Europe within the current context of definitions for energy positive buildings. Pascal or Christian, could you respond to the question in relation to the comfort level indicators that have been included in the definition of energy positive neighbourhoods?
Only I can think of that can relate to this is whether you turn up or down the heating of your household. But as we are not controlling it, I think no, we have no we are not measuring it and have no indicators. We're just advising the residents to it. If I understood this correctly.
Yeah. Yeah, I think Christian's right. Our indicators are designed to measure the energy positiveness of an area, and on that the individual building occupants or facilities managers themselves will control the temperature levels, etc., in the building. And we'll move on to the next question, which is, have we identified EU countries where the business potential is higher for energy positive neighbourhoods in terms of national incentives and regulations, etc.? Currently, yes, we have. Some European countries offer a very, very clear market for energy positive neighbourhood service providers. In particular, Denmark, Finland and Norway and Sweden are all potentially extremely strong markets. They all have mature district heating markets. They are moving towards smart distribution networks. And in Sweden, Finland and Norway in particular, spot price tied electricity contracts are commonly marketed. This is partly because these countries all operate on the Nord spot pool, which is a very efficient market in that 70% of energy is traded on this market, which means the market actually reflects a national electricity demand. And this makes it a much more efficient market than countries where most electricity is traded by bilateral agreements, and the wider energy markets, the day-ahead markets and the spot price markets don't necessarily reflect energy demand. Also, in the countries that we've mentioned, Denmark, Finland, Norway and Sweden, are also implementing the Energy Performance and Buildings Directive vigorously, so they have highly energy efficient buildings, and they have residential market structures which favour the development of efficient housing and commercial and regulatory practices which support integrated energy contracts and lifestyle and life cycle approaches. Yeah. Now let me see the next question. Yes, the rehabilitation of existing areas. Christian, would you like to say something about the renovation of existing areas in relation to the project, or would this be better handled by Pascal? Because we did do some work looking at how to improve the energy performance of existing buildings at the IUT site. Yeah.
I think it's better for Pascal to answer.
Okay, thank you. Pascal?
Can you hear me? Yeah? For the IoT side, the question was raised because the IoT, most of the buildings were constructed in the 70s, so most of them need refurbishment. And the Atlas tool developed within the project helped us to test some different scenarios of rehabilitation and estimate the return on investment for such a process. So we get some information from the IDES project about potential rehabilitation of the site, and also this rehabilitation can include renewable energy sources integration, and this has been tested through the tools, the Atlas tool, so urban planning tool, but also through the simulation performed in the EMS in order to identify the way this renewable energy sources cover the actual demand of the site and in which way this could be implemented.
Thank you, Pascal. I think that was a very clear response. And there's the next question, also in relation to the French pilot site. It says the electricity price was fixed. Would the simulation results change if electricity price would vary hourly, as in the Finnish pilot?
Yeah.
I think that is true. Do you want to deal with this one, Pascal?
So we have a fixed tariff in France, but in the case of the IoT, we have different tariffs along the day. So corresponding to peak hour consumption and to low hour consumption. So this is a fixed tariff, but with variable value during the day. So in fact, if we have also variable tariffs to sell, for instance, electricity to the grid, we would have different results, I assume, and they will be better, I assume also.
Yeah, we've done some simulations at Teesside University, and while there is a differential tariff, a time of day tariff in France for the electricity that you buy, what doesn't currently exist is a dynamic or price time-dependent tariff for the electricity you sell. That's a fixed price tariff. And yes, the model would, the approach adopted would show a much stronger business model if there was also a variable tariff for the electricity that you sell. Okay. Okay. Do you consider internal mobility in a neighbourhood too? Christian, would you like to respond to this one?
I'm not sure that I understand the question correctly.
Okay, I think it's looking at the issue of whether or not, when we're thinking about the development of an energy positive neighbourhood, do we think about changes over time? And the Atlas Urban Planning tool is designed to cope with simulating and modelling the energy infrastructures of the area over time, over 10 years, over 20 years, over 15 years. And within that, we do consider that the residents of the area might change in age and type, etc., if that is what the question was about.
Yeah, all of our KPIs that we are tracking and following are of course changing over time according to the behavior.
Okay. Previous experience of user awareness, shall we move to the next question, as a means to reduce energy use, have shown that energy use tends to bounce back up after a short period, e.g. a campaign. Do you have any lessons learned about having a long-lasting energy use reductions? Would Pascal or Christian, would you like to respond to this, or would you like me to give an answer?
And try to give some arguments. So indeed, all the awareness interfaces have a very short impact on the user behaviors, on the occupants' behavior. This is a problem, and I think we have faced the same problem in the IDES project. And the solution could be to involve them through maybe a competition process So to provide them with sort of ranking according to the building in which they work, and to engage them to make a better energy consumption, a better energy management, in order to have a better ranking in this in the site. So this is a way to have a long-lasting energy use reductions thanks to user awareness interface. But we didn't implement it during the project.
Mm-hmm. I think sometimes we have too much reliance on behavioural change and user awareness within these style of projects and these approaches to reducing energy demand. User awareness is a very good idea. It's really good if people can have an idea about how much energy they consume and how they can change it. But quite often, a lot of our energy demand is actually physically constrained by the buildings and places that we live. So I think we have to accept at some levels that user awareness and behavioural change does not have a large impact on energy demand. However, this does vary from project to project, but I think really the idea is that we focus on the energy infrastructures and the building infrastructures and how we produce, generate and distribute energy as a way forward to improving both the integration of distributed renewable energy generation into current energy networks and reducing overall energy demand. I've also missed a question here related to indicators, which I seem to have skipped over. Let me see. What indicators were used to define the needed energy flexibility on the building level? Here again, I'm not altogether clear what the question's asking. However, we do have a copy of a paper written and presented at a conference earlier this year available on ResearchGate, which you're quite welcome to look at and review, and I would welcome any emails in relation to this question. And we have a final question, I think. Can other actors integrate into the consortium? It could be interesting to include the characteristics of Spain, bad legislation and good weather condition for renewables. Not in this particular consortium, as the project finishes at the end of this month, but I do agree that it's a very interesting question that we have explored within the project, looking at how legislation impacts on the possibilities for the business model. In Spain, I believe that it's not possible for small-scale energy producers to sell electricity back to the grid, as I understand it. And I'm not sure about the situation of differential tariffs. However, I do think that it's very interesting to explore the possibilities for the notion of an energy positive neighbourhood in more detailed pilot studies in different European countries. And it would be a very nice project to carry on from the Ideas project. Do we have any further questions? Or would anybody like any further clarification?
No further questions as far as I can see in the list. I would like to thank you very much for today's webinar. I don't know if you have any closing remarks.
As a final remark, I would just like to thank everybody for attending and for their interesting questions. And please do not hesitate to get back in contact with us if you are interested in any of the findings or technologies related to the Ideas project. Thank you.